In this video I will show how to use the Tracker video analysis software to track and analyze the motion of a simple pendulum. So the first thing you'll want to do is to get Tracker. If you just search for Tracker in physics, the first hit here should be the Tracker software. And then you can download the latest one for your operating system, and it ought to install all of the video stuff that you need. If not, it has help files here to troubleshoot any issues that you might have with the installation. Okay, once it's installed, you should be able to open it on your computer, and it comes up with a screen that's something like this. Okay, so mine might not be quite the newest version, and the people that made it, they update it and add new features to it all the time, so they might look slightly different, but the basic features should be the same. So then you take the video that you're interested in tracking, and I've got a video that I've prepared here, and you just drag it into the screen and it will load the video into the program. And in here you can watch the program. It's slightly slowed down the playback of the video. So what I've done here is I've just filmed on a white background the pendulum bob of a pendulum. I've written down its length and things in case I need it for any analysis that I want to do. And what I need to do first is just tell the computer how big everything is. A couple of things I should note about the video is that it's useful to clip it so that it only includes the motion that you're interested in actually tracking, so there's not lots of extra frames either side of it. It's also essential, if you want to do any measurements, that you have something of known length that's at the same depth in the shot as the object that you're tracking. So you can see that I've got a ruler here, and it's not far behind where the pendulum is swinging back and forth. So at 20 centimeters here should correspond roughly to 20 centimeters of the motion of the bob. Okay, so now we have this this object, and we want to just tell it how time works in the video. So you can do that by clicking this little clip settings button. And here it says start frame is 0, step size is 1, end frame is 107. So there are 107 frames in my video, and it's at 30 frames per second. And this particular video was shot at 30 frames per second. If you have a camera that can do higher speeds, you'll need to manually change the frame rate here. So iPhones can, I think, shoot at 120 or some even 240 possibly, which is useful if you want to capture something that's moving quite fast. Otherwise this works well. So we'll leave it at that. And then what you want to do is, I'm just going to maximize this window so it becomes a bit clearer, is to create a ruler, a calibration stick, like this, that will tell it size. So that is 20 centimeters. I'll just tell it that that's 0.2 meters. So now the software knows how much time is passing and how much distance is moved through with each passing frame, kind of thing. We can now create a point mass. Okay, and then it automatically jumps back to the first frame. And now you can auto track an object as long as it's recognizable in every frame. So what I'm going to do is just take the left edge of this pendulum bob, which is a very clear black-white boundary with white on the left and black on the right, and there's nothing else in this shot that looks at all like that. So I'm going to hit Control and then Shift, and my cursor turns into a round crosshair. And then I'll just click once, and this auto tracker box comes up. This is the frame that I've chosen to track, and it's going to look for that in every single subsequent frame. And so if I now hit search, it'll go through and it will track that point in every single frame. And we can see here on the right, it's generating a graph of horizontal position against time for that point, which looks very much like the graph for simple harmonic motion. Okay, and now it's done. So I'll get rid of this box. So now we can have a look at this graph here alongside the video. So it's kind of cool that you can let the video play and it will move through the points. So if we want to stop it here, we can see that it's now at its extreme position on the left, which means we have a big negative displacement. I haven't set what 0x, but I'll do that in a moment. And as it swings through its positions, we can get all of the different displacements. We can see it forms a nice sinusoid. Okay, now we can add a set of axes and decide where we want our 0 to be. So now I've placed it a bit too far to the right. If I just scroll through here and try to find the position where the string is vertical, or as close to as possible, like somewhere around there probably. This is assuming that I held the camera straight, so that doesn't look quite right. It's further this way. That's too far. So what I'm doing is I'm looking at the graph to make that 0 point in the middle, and it looks like it has an amplitude of about 4 centimeters. Oops. That looks about right. Okay, so now this graph will also be centered around 0. Okay, and the kind of cool thing is that this system is able to calculate all kinds of things for us. So we can, for example, let me just get rid of that. We can have multiple plots here. And I'll get rid of this table. The data can be exported if you want to use other graphing software. So this is a graph of position against time. We can get a graph here of x velocity against time, which we can see is 90 degrees out of phase, as it should be. And we can get x acceleration against time, which looks a bit squiggly, but we should be able to see that it's basically 180 degrees out of phase with the position. By the way, if you plot too many frames, it can end up looking a bit like that. What you can do to remedy that is just change the number of frames that you do. So if we reduce it to every third frame that we track, then it'll look a little bit neater because it doesn't do every single point, and there's a bit of variation from point to point. Okay, so now we have x, the position, the velocity, and the acceleration, and we can clearly see their phase relationship here, which is one of the things that they need to work on in level 3 physics. The other graph, of course, for simple harmonic motion that's useful is the acceleration versus position graph, which shows that the acceleration is directly proportional to the position and in the opposite direction. Basically, whenever the position is negative, the acceleration is positive. Whenever the position is positive, the acceleration is negative. So that's like the definition of simple harmonic motion in that graph. Okay, so as you can see, it's quite easy to generate loads of interesting information, and if you really want to get precise, you can work out what the gradient there and figure out properties like the length of the pendulum using this data, or the acceleration due to gravity if you know the length accurately. You can export, as I said, any data that you want. So in the table you can decide what you want here. So you could have x velocity, you might want kinetic energy. Although I should say that for kinetic energy you need to define the mass of the object that you've been tracking for it to be accurate, which you can do. And any other information, and you can just, this data can just be cut and pasted out and into any other graphing software that you want to use. Okay, so that's a basic introduction to Tracker.